since the dawn of the agricultural revolution, food has been produced a particular way. And the way it has been produced is that it's in rural areas. And if you think about how forests grow and evolve and die, essentially they operate on their own cycle. They don't need any intervention from us. We've changed that around in our food production systems. What we do is we suck more out of the earth than the earth is capable of giving. We pump fertilizers, pesticides, herbicides, and so on and so forth. And as a result, we've devastated the planet. This question was not relevant a few years back. Nobody cared about sustainable urban food production. And we'll see why it's more relevant today than it was. And then we'll see whether or not it's possible. And sustainable means a number of things. It has to obviously work for the environment. It also has to work financially. What we'll see is that the reason urban food production doesn't work today is that it is too expensive to be financially sustainable. So behold the mighty tomato. Why should we behold the mighty tomato? It is, if you think of what it does for us, it is almost the perfect food. So if you think about how much actual caloric food value we get out of it and how much nutrition we get out of it, it is right there in the top corner. Compared to, for instance, nuts, very nutritious, but you have to eat a lot of nuts to fill yourself. And then, of course, you have chicken McNuggets, other wonderful things that our food production systems have given us, right? Which fill us up, but are not very nutrient-rich. Now, what does that have to do with urban systems? In a city like Oakland, one of the things we see is that the poor don't have access to good food. Right? And the way that manifests itself in what people eat is this. So if this is essentially what low-income people eat versus higher-income people, and what you see is that the only thing that lower-income people eat more of is sugars. And this is not just a scientific issue. This is an issue of economics. There's a reason why there is no Whole Foods in West Oakland. Right? Whole lot of considerations that food companies and the grocery stores have to go through. And as a result of that, if you are a working parent working more than one job, you come back, you're really tired. You can't actually go the extra mile to get good vegetables and cook. And as a result of that, you see the health consequences. So not surprisingly, lower-income Americans are more obese and suffer all sorts of diseases that higher-income Americans don't. Now, some of these pictures are not from Oakland, but might as well be. The food desert issue is a massive one, which is that in virtually every inner city in America, you cannot get good food. You get instead this kind of stuff, right? So this is an FDA map of Oakland, and there are a number of categorizations of food deserts, right? The yellow and the orange and the red. And guess where the McDonald's are, right? It is not surprising that the places where you get Whole Foods is not the places where you get McDonald's. So that's the one problem about access to nutrition. The other problem is about the environment, which is we produce ridiculous amounts of fertilizer, which fertilizer unto itself is a very carbon-intensive thing to do. It's also devastating waterways. What we do is we pump all these runoffs into our rivers and oceans, and we're killing off sea life. Then another problem that nobody in Oakland needs to be reminded of, nobody in California needs to be reminded of, which is water. We'll see how much water it actually takes in just a bit. In addition to that, you have pesticides, herbicides, all sorts of things that we do to suck, as I said earlier, more out of the earth than the earth is capable of giving. And then, after we do that, we ship stuff far, far, far away. Not as far as the supernovas we're talking about, but certainly it does not make sense to grow stuff in California and ship them to Michigan, as good as that is for California's economy. Now, you add all this together, what does that mean? So if you take the tomatoes, the mighty tomato again, consumed by the city of Oakland, here's how much its footprint is. It is 150 million gallons of water. So all the tomatoes in the city of Oakland in 1 year. It is, 9,000 gallons of fuel to transport the stuff, and just a ridiculous amount of pesticide and herbicide. So let's come back to our question. Is it possible to grow food sustainably, locally, and cost-effectively? Well, when we think of local food, this is what comes to mind: community gardens. And the problem with community gardens is this: they are well-intentioned, but they often depend on charity. They often depend on subsidies. And so what you see is for every dollar you spend on things like tomatoes in typical conventional rural farms, if that were grown organically in rural areas, it would cost $1.50 or so. If it were grown in community gardens, a lot more, conventional or organic, right? And so this is why organic farming is not financially as sustainable, and community farming is not financially sustainable. And so the question is, how do we then make this more cost-effective? The other part of this equation is that we're solving for the transport problem, but it's not clear that local food production is actually environmentally that much more sustainable, because who knows how much water is going into it? Sure, usually community gardens tend to not use fertilizers and pesticides and so on, but there's no law against it. And honestly, if these chemicals were used in a city, it'll probably do a lot more damage than if it were used in a rural setting. So now, if you think about the various ways in which food production systems have evolved, historically it's been here. It is just using soil. So the mediums being soil, some sort of a substrate, and then you get more and more sophisticated, and we'll talk about some of the more sophisticated systems in a second. And then you have just a regular old outdoor farm. You have greenhouses, and then you have what I'd like to call a hyper-controlled environment. So greenhouses have been around, and they're getting increasingly sophisticated. And I believe that the really interesting stuff is up there, where you can super control the environment, so that instead of the old agricultural systems where we had to pump stuff into the environment to fight off the harshness of that environment, all of a sudden we're making the environment much more conducive to growing. So in other words, imagine food production systems where if it's in a shipping container, where things are pretty well controlled. And we'll talk about what those controlling mechanisms are. So rather than having a farmer who really has to understand the soil and insects and the rain patterns and so on and so forth, all this stuff sort of gets automated and controlled. Right? A little bit like those cappuccino machines where my cappuccino making skills are no longer relevant, which is very sad, because you can press a button and get stuff that's okay. So this is what we're trying to do, is precision agriculture. So three systems. The first is hydroponics. Essentially, the idea is that instead of the roots being buried in the soil, it's in water, and that water keeps getting circulated. The water has nutrients, and because of that, because you're reusing that water, you reduce the amount of waste. Right? Then you have aquaponics, which is much, much more interesting, which is you actually have now in that water fish. So the fish poop, which my daughters get a kick every time I say that, actually generates nutrients. Obviously, you can add additional nutrients as well, but now you're starting to get sort of a closed-loop system where you don't have to add a whole lot of new stuff. And then you have a much more interesting, much more sophisticated mechanism called aeroponics, where you're actually spraying stuff onto the roots, right? Where the roots, as you see, I don't know if you can see in that picture, but the roots are no longer, they're not buried in anything. They're suspended in the air, and you're spraying water, you're spraying nutrients into the roots. Okay? Now, if these systems are used at scale, and already a number of people are starting to do this, there's a tremendous savings in terms of water. For some of these things, you can get by with 5% of the water, a lot less of the fertilizer. And because these are now in controlled environments, indoors, in greenhouses and such, you're not exposed to things like pests as much. So you don't need as much pesticides. And a lot of the systems that we're looking at now, they use almost zero pesticides. And then the challenge now is even these systems, and there are a number of innovators that are growing vegetables this way. Now, many of these folks are scientists who've taken off their day jobs and starting to become farmers. even though they're doing really interesting stuff, it's still not financially feasible. For every dollar, again, it's costing them $1.25, $1.50. And that's a fundamental challenge they're trying to overcome. And the reason is that if you look at this greenhouse, a lot has to go into the actual structure. The glass is expensive. It gets dirty. Lighting. There's energy costs involved in lighting and heating. And then hyper control. So for instance, if you go into one of these systems, one of these greenhouses, you have to wear this suit. Otherwise, you're actually bringing in pathogens into the system. And this gets expensive. How do you make this less expensive? Then the other problem is that, interestingly, a lot of these folks are not growing tomatoes. They're growing lettuce and greens because these are single cycle. Right? If it's a single cycle, you don't have to worry about pests coming in the second and third cycles, whereas tomatoes, on the same plant, you have multiple cycles of fruits. Right? And so they haven't cracked the code on how to grow things like tomatoes yet. And then the other thing they're struggling with is that because the science is not yet known, it's all experimental right now. Right? They're tinkering with this. These are really interesting tinkerers, but nonetheless, they are tinkerers, and they don't know the answer, and sometimes the losses can be devastating. And so that lack of science is actually really hindering the development of these systems. Now, what kinds of things can we do? Turns out that plants don't need as much sunlight as they get. Some studies show that you can actually do strobes, maybe even 3 or 4 seconds out of every minute, and that could be enough for plants. And what we don't know, again, is there's some early science indicating this, which is you can actually control the wavelength and actually get more out of the plants by exposing them to some wavelengths than others. And again, a lot of research has to be done here. Then you have this notion of a nutrient recipe. Right now, we use a baseball bat to grow plants. We just throw everything at it, whereas we don't need to give that much or even the same generic mixture of fertilizers. Right? So understanding what crops need exactly what and giving them exactly the precise amount so that not only are we wasting less, not only are we creating less waste, but the plants are actually better off. Because as you know, you can over-fertilize the plant. And by the way, this picture isn't clear, but there's actually the possibility that we can use local waste to do that. Now, the challenge with local waste is that if you go into a compost bin, you have no idea how to make that precise. Right? So again, a lot of research has to go into whether or not you can take existing waste and make that more precise. And then, as I mentioned earlier, there's this level of hyper control where instead of having to expose growth and your produce to the elements, now you can sort of I'm not exaggerating. I'm willing to bet that 10 years from now, in iPhone version 46, you can actually sort of control what kind of light, what kind of humidity, what kind of temperature your plants get every minute, and you get really interesting sensors in the ecosystem so that there's this feedback loop. Right? So all of this is quite possible. And then the other thing that can be done with things like greenhouses is instead of the traditional glass, can we actually have interesting structures so that now the glass is it is less resistant to things like dirt. Dirt, as you know, occludes light. Right? So a number of really fascinating things need to be done, but currently the food production systems don't lend themselves to this kind of research. So we are actively looking into some of these questions. So let's go back to the original question. Is sustainable urban food production possible? What do you say? Well, I'm a scientist, so I'll only lie to you when I can prove it with data. So I've only talked about the mighty tomato and the mighty lettuce. What I haven't talked about is the real stuff that really consumes a lot of the resources. Right? So I think we can grow vegetables, and that can be very sustainable. But at the end of the day, the grains are what consume most of the resources, whether it's water, whether it's fertilizer, pesticide, and so on and so forth. And I must say, I'm scratching my head about a solution for the grains. Vegetables, yes. Grains, maybe. We'll see. Thank you.